Hello, hello students. We are meeting for our next lecture of environmental chemistry, and we were discussing green chemistry and technology for sustainable development. Under that, in the last lecture, we have started the discussion of 12 principles of green chemistry, and in that, we have discussed the first six principle, that is first principle is the minimization of waste product formation. Second is atom economy. Then third is avoid the use and formation of toxic materials. Then fourth is design and use of non-toxic chemicals or having minimum toxicity. Then fifth is minimum use of auxiliary substances. And the sixth one is minimum energy consumption. Then now we'll move ahead for the seventh principle, that is use of renewable sources. Here renewable resources means here for industry you need raw material, okay, and you need energy, okay. So here as far as energy is concerned, you can use electricity, you can use fossil fuels, you can use solar energy, you can use biomass, biogas energy, or other nuclear energy or other kind of energy. These are the various resources of energies are available. But here renewable means the resource which is not going to end, which is not going to deplete completely, okay. Means here if you take example of solar energy or biogas kind of energy, or hydroelectric, these are you can say renewable energies. They are going to be there for a long time, they cannot be depleted completely. But energy sources like fossil fuels are going to deplete very fast. So here it is advised that use we should use renewable energy. So if it is possible technically and economically, then renewable sources such as biogas rather than non-renewable sources like crude oil should be used. The continuous use of non-renewable source have depleted them beyond the repairs. Means all of us know this very well, because since after you can say industrial revolution, the major you can say emphasized emphasis was on the fossil fuels. Now these are now realized, people have realized that they are non-renewable, and these sources has depleted to such a great extent that they can our future generation will be deprived of these uh, energy resources. So one has to uh, take into account that this principle promotes the use of raw materials from renewable sources wherever possible. You should not use non renewable sources, okay, because that is going to somewhere going to lead the non sustainable development. Here in this chapter we are going to discuss for technology for sustainable development, means which will sustain for our next generations, okay. So we have to think accordingly. The over exploitation of these non-renewable feedstock such as fossil fuel, petroleum for manufacture of various products has depleted these sources, that everyone knows. So this excessive and uncontrolled use of these non-renewable resource puts a burden on the environment, okay. So that one has to take into account that one should avoid the excessive use of these non-renewable resources. Rather we should not be dependent on these resources. We should shift our technology towards the use of renewable sources like solar energy, biogas energy, or hydroelectric energy. As against this, the use of renewable sources such as those of agricultural or biological origin reduces the burden on environment, because renewable itself means the cyclic process. Okay, somewhere after use, what happens with the resource? It is going to refill again. Okay, so if it is going to be a cyclic, then there is no formation of unwanted or undesirable or problematic or threatening kind of byproducts. Okay, so that will reduce the burden on environment. So environment need not to do anything else, otherwise it is going to create the problem. So also it also ensures that the byproduct waste are generally biodegradable. Means if we are going to use natural renewable sources like agriculture or biogas, then it is going to be a biodegradable source. Means here whatever products will be formed, they will be biodegradable. That means they can be recycled again, and the source will be sustained for next generations. So example of this practice is for example, synthesis of bioplastic or biopolymers. Okay, means here not only energy sources, the materials which are to be used, they should be you can say renewable sources. Means here earlier the plastic which was formed like polythene or polystyrene, that is not going to degradable, that is not going to degrade, or that is not going to disintegrate naturally. They are not biodegradable, means they cannot be recycled in nature. But nowadays people have come to the conclusion that we should think about that the renewable sources like bioplastics and biopolymers. Okay, so here polyhydroxy alconate, you can use it, polyhydroxy butyrate, polyhydroxy beta valerate are obtained by using microorganisms. Okay, means these polymers can be synthesized by using microorganisms which use the lower fatty acid to produce these biopolymers. Okay, means these are, you can say, biodegradable bioplastic or biopolymers. Carbon dioxide is the feedstock in the synthesis of polycarbonate. Okay, means here carbon dioxide is consumed for preparation of polycarbonate. This polycarbonate glass is nowadays a very safe glass, especially for the windshield glass of the four-wheelers. Okay, so this polycarbonated glass is not harmful if it is broken down. Okay, and at the same time its raw material is carbon dioxide. Means we need not to, rather we are recycling the excess formation of carbon dioxide. Green synthesis of furfural from biomass. Furfural is the basic material for synthesis of polymer material, and this furfural can be obtained in nature. You can synthesize in lab also, but you can prepare it by a biological process, biochemical process, that is from biomass. Okay, then green synthesis of adipic acid and catechol. Okay, adipic acid is a monomer for polymer. Okay, like nylon 66. Okay, in that polymer adipic acid is one of the starting material, so that can be synthesized by green chemistry. And catechol from biomass. So catechol is also dihydroxyphenol, which is also very important material. Okay, so these are the examples of the practice which exercise this principle, that is use of renewable sources. Means here renewable sources means not only the renewable source of energy, but renewable source of material, feedstock also. So that one has to take care. And now we'll move ahead to the next principle, that is minimization of steps. See, when you go in the lab, up till now, till FY, SY, in SY you have prepared one step synthesis, that is conversion of phthalic acid to phthalimide. Okay, that is one step synthesis. But when you go to synthesize some compounds, you need to carry out multi-step, two step, three step, four steps. Sometimes it goes up to 10 steps also. So why these steps are required? Okay, so here we'll discuss one example. For example, reaction of M metahydroxybenzaldehyde. Consider this. Now this consider this starting material and consider the last, that is metahydroxybenzoic acid. In this conversion, the aldehyde group of this compound is oxidized to carboxylic acid. That is the main aim. But the problem is, as there is a presence of OH group at the meta position, if we directly carry out, see the second step where the oxidation is carried out. Okay, if we carry out the oxidation directly of that benzaldehyde, there is problem with this OH also. This OH is certainly going to create problem, because that oxidizing agent is going to react with this OH also. So there will be some undesired, unwanted reaction will be there. So to avoid that, first you have to go for blocking the OH. How will you block? First you have to treat with the toluenyl chloride in presence of hydrochloric acid. This is called as methyl chloride. Okay, methyl benzene. Okay, this methyl chloride will react with only with OH group, and it will be converted to ether. Means phenol is converted to ether. Then you bring about the oxidation. Now here there won't be problem with that ether linkage. The oxidizing agent will react only with aldehyde group, that will convert CHO, that is aldehyde, to COOH, that is carboxylic acid group. Now once it is converted, you want your OH back, then again you have to go for deprotection. Means you have to remove that methyl benzene group, and you have to again convert it to OH, and for that you have to go for hydrolysis. Okay, means here the desired conversion of aldehyde to carboxylic acid has one step synthesis has increased to 1 to 3 steps. So if we are going to increase the number of steps, will require more number of chemicals, there is chance of formation of more number of side products or waste products. There are chances of lapse, wastage of energy, wastage of material. So all these things are going to happen if the synthesis is a multi-step synthesis. So in green chemistry, you have to go for innovation of such method of synthesis where there will be minimization of steps, rather if we can go for one step synthesis, that is within a one step can we get the conversion from starting material to the end product. But this is if we go and follow organic chemistry rules, mostly it is not possible. So if you want to bring about this change, selectively change, for this example which we are discussing, selectively if you want to oxidize this aldehyde group to COOH group without any effect of OH group, then such selective changes, selective reactions can take place with biocatalyst. If you are using any enzyme, any biocatalyst, then these changes one step synthesis is possible, where you because of reduction of number of steps, there is no chances, or there are no chances of formation of waste product, byproduct, and selectivity of the reaction of the enzyme will not allow the formation of any byproduct even in that single step also. and rather it is a recyclable raw material, means the enzymes are recyclable. So many times these biocatalysts do not require any protection, deprotection, so it is a selective reaction. So you can avoid by using biocatalyst. So you have to go for invention, or you have to go for in search of such biocatalyst that will avoid the multi-step synthesis by one step synthesis. So that will be result in minimization of steps. So that is the principle behind minimization of steps. Now I'll go to the next principle, that is use of catalytic reagent. Catalytic reagents means uh, here use of catalyst is beneficial. Catalytic reagents are much effective than stoichiometric reagents in chemical synthesis. Means here if you take just reactants, change its concentration and try to bring about the change, if you use catalyst, then the results are very nice, or more yield, or economically and environmentally both are very useful. Use of catalytic reagent reduces energy required for reaction. That all of you know. What is the role of catalyst? It reduces the energy of activation. Means you can bring about the change in the small amount of energy. So that is the first benefit, that you avoid the excessive use of energy. Okay. Then it also reduces the burden on environment, because here there are many benefits of catalyst that will be resulted in beneficial use of catalyst. So what are those advantages? That is 100% atom efficiency can be achieved. Means here only reactants which are necessary for the required change are be used, and the catalyst will bring about the reaction between them. Thus by 100% atom efficiency can be achieved. Catalyzed reactions are faster, and therefore energy is saved. Okay, so catalyzed reactions are why they are faster? Because energy of activation is reduced. So thus by within a small amount of energy, you can bring about the change, and therefore reaction becomes very fast, and so the even time as well as energy is saved. And it also ensures the better yields. Okay, because catalyst is more prone or more lenient towards selective reactions. Therefore better yields, selective reaction brings the better yields of the product. Then maximum selectivity can be achieved, that I told you, because of better the better yields are achieved because of maximum selective. Means no need of just now in the earlier principle we have discussed that protection, deprotection, such kind of steps can be avoided. Okay, maximum utilization of starting material and minimum generation of waste. Means here in the earlier advantage I told you, it is selective reaction, therefore maximum conversion. Okay, second thing, as it is selective, there is a minimum generation of waste. Means there is no possibility of any side reaction will take place, or any other possibility. The reaction is very selective. So maximum yield and minimum generation of waste, that principle is followed when you are using catalytic reagent. So here one example one can be explained. Just take the hydrogenation, means reduction of say double bond, that is alkene. You can use catalyst, reaction will be fast. If you are not using catalyst, then it becomes difficult to get the yield. So if there are no less yield, obviously atom efficiency will be reduced. So there are n number of such reactions can be discussed where you can use the catalyst. So organometallic reagents is one of the fast growing, or has fast growing branch of organic chemistry. So similarly, you can have a number of such examples in organic, inorganic, or other chemistry subject, and you can find out them, and you can quote it here as a catalytic reagent. Then we'll go for the next principle, that is degradation of waste. Means here up till now we have discussed use of renewable sources of energy as well as starting material, then minimization of the steps, then use of catalytic reagent. So all these first nine principle, they are pointing towards, they are leading towards the development of such technology where there will be no formation of waste product, so that there won't be any requirement of the how to deal with that, what to do with that waste product. It should not be let it go in the directly without processing. We cannot let it go in the environment. So here one has to think about one more possibility, that as far as possible all these principles will be followed, but if for a certain synthesis, if we cannot follow these rules or principles, then there is going to form the waste material. Now what to do with this waste material? So at the end of the reaction, products will be released in the environment or discarded as waste, should which will be formed at the end of reaction, that should be degraded or break down rapidly into harmless product. That is, after they should not be remain in environment. For example, DDT. All of you must have heard about DDT. So what is the role of DDT? DDT is a very good pesticide, very effective pesticide. This is polychloride compound, and it is widely used unknowingly in earlier days. 22 or 30 years back, it is used to be sprayed in publicly on all the sanitary pipes or everywhere wherever there is a garbage. But at the same time, at the time people were not knowing, but now it is realized that this compound is very stable. Means once you spread that powder, whatever the required amount of that powder is necessary to kill the pest, that is used. But what happens with the excess? That is stable compound and that is not going to degrade easily. So due to this stability, it remains in environment and causes environmental hazards. So biodegradable pesticides are therefore preferred. Means afterwards people stop using DDT, they go for biodegradable pesticides. Means if at all this pesticide is sprayed or used excessively, the excess quantity will be recycled or biodegraded, so that there won't be any environmental harm. For example, you can use pheromones and attractants are these are the chemicals released by insect to attract or communicate with the member of particular species. So these chemicals are sensed by insect. Okay, so can be used to trap the insects and control their population. So these pheromones or attractants chemicals need not to be synthesized, they can be extracted from nature itself. For example, melon is a good fly attractant, while methyl eugenol is an attractant for many insects. So if you just spread it on particular area, so all the fly or the threatening or harmful insect, they will be collected at a time and you can destroy them. Okay, so juvenile hormone analogs can be used to arrest their growth in larval stage. For example, methoprim. Okay, so these are called as fourth generation pest controls. Means you have to, first of all, you need not to go for synthesis because that is available naturally. Just extract it and use it. So in a way, that is you can say our that will be responsible. You can degrade those waste material very easily. The hormones are biodegradable and do not create environmental hazard. Some plant extracts containing hormones can be used for this purpose. So you can, as I told you, you can extract it from natural resources. Polymers which degrade photochemically can be used as starting material for some products. Means such you can have a number of such examples where you can go for natural use of natural substances, chemicals, where excess use, if by chance has taken place, then it can be biodegraded. Okay, so degradation of this waste has to be taken care of. Then we'll move ahead to the 11th principle, that is monitoring the generation of hazardous substances. Means here again we have to think about first 9 principle, and whatever we discussed up to 9th principle, if by chance, if for a particular chemical, if it is not possible, then it is going to form the hazardous substances. So if by chance due to or maybe there may be any problem with the operating system, means like at the beginning I have given you the example of Bhopal tragedy, where due to lack of maintenance of cooling system, that methyl isocyanate gas has released in air, which uh, which has caused the casualties in lakhs. In lakhs, many people have died because of that. So here, manufacturing process should be monitored by appropriate computerized system, so that they can allow for real time in process monitoring and control prior to generation of hazardous chemical. Means if by chance any unwanted reaction is taking place, and if unwanted or poisonous or hazardous chemical is going to form, that will be sensed easily. Here I would like to give one example. All of you know Dr. Chabuk Swar from our department. Okay, he has in his research he has synthesized the nano composite polymers. Okay, and those nano composite polymers can sense the ammonia gases and other gases. Means as soon as suppose such sensors are fitted in the industry, as soon as there is a release of these gases, they will be sensed easily, and immediately they will be indicated. That means monitoring of release of such hazardous gas can be achieved. Means this is just one example from his research I have given. There are n number of such sensors are nowadays in the market. You can use, and you can still develop the computerized system, so that as soon as such hazardous chemical is formed, it will be immediately indicated, and can be safety measures can be followed. So this is done by continuous monitoring in different processing units, particularly in the chemical industries and nuclear reactions, which helps to avoid the accident as well. Means the example which I discussed, that Bhopal tragedy, if the monitoring system was there, it would have immediately indicated the release of such poisonous gas, and it could have been avoided. But that was not happened at that time. So this has that has become very important. Therefore this principle is included in this 12th principle. Then the last 12th principle is use of safer substances. Means processes and substances used in chemical industries should be selected in such a way that they can minimize the occurrence of the chemical accidents, explosions, fires, and hazardous emission. Means as far as possible, don't use the harmful chemicals. As far as possible, use the safer substances. Okay, this can be understood as follows. Okay, one can understand this. If the chemical process uses gaseous substance, okay, if the chemical process uses gaseous substance, possibility of accident including explosion is relatively higher compared to the when using non-volatile liquids and solids. This is just example. This is not possible always, but if we can use the chemicals in the non-volatile form, or solid or in the liquid form, then use of gas can be avoided. But if you need, you have to, you can use it, but as far as possible avoid such kind of chemicals. So that is the 12th principle, that is use of safer substances. So all these principles, in short, in conclusion, we can say that we should not allow formation of waste product, formation of byproduct. We should use renewable sources. We should use, we should follow minimization of steps, or use of minimum energy. And if at all you want to use, you can use the safer substance. Okay, you have to monitor, you have to go for use of biocatalyst or use for catalytic so these are collectively helpful to maintain the environment, and we go for sustainable development that will sustain for future generation. Means our development in our development in our generation will not be curse for the next generation. It should be a boon for next generation. So this is the 12th principle. So for today's lecture we'll stop here. We'll meet our in our next lecture. We'll discuss the next point, that is green chemistry and sustainable development. So for today's lecture we'll stop here. Thank you.